at the delete or remove function for a singly linked list. In the previous section I looked at inserting, and this is the output we got. So we're first going to look at removing the head and removing the tail out of the list. I've already written those functions. So this function over here removes the head of the list. First we check, is the list empty, as always. And I will make a video on throwing exceptions, but basically you create an exception of empty list exception type. You call it empty exception, and you create a new one, and then it will throw it if the list is empty. And if it's not empty, then we check, is head.next null? If head.next is null, then we simply assign head to null, because then we can safely delete the head and nothing comes after head or before head. Well, nothing ever comes before head, but yes. Else, we know head.next is not null, so we just say head is assigned head.next. So that means that head will point to head's next. So in that way we are deleting head, and then we just decrement our size. Okay, then we can also remove our tail out of the list. So in this case we once again check if it's empty and throw an empty exception. Else, if head is equal to null, we just return, because then there's nothing in the list. Else, we say the dl node prev, which is a temporary previous variable, is assigned null, and temp is assigned head, and then we're just going to traverse through the list. So while temp.next is not equal to null, we say prev is assigned temp, and temp is assigned temp.next. So we're making prev temp, and we're making temp its next. And now temp is the tail of the list, so we can say prev.next is assigned null, because prev used to point to temp, and now we're making it point to null. So in that way we're deleting the tail of the list, and we're saying size minus minus to decrement the size. So now we're going to use these functions within our remove function. So let me just create some space here. So I've defined 3 variables. This also throws an empty list exception, by the way. I've defined it as the position, which is the position of the node we want to remove, that we have defined. And there's also a function getPosition. So let's quickly look at that. It simply gets the position of the value to be that we want to find and delete. And if it isn't in the list, it returns -1, then we know it doesn't exist. So we simply traverse the list. We say if it is empty, we return -1. -1 is our indicator that the element is not in the list. Else, if head is not equal to null and head.value is equal to the value we're looking for, we return a 0, because then it's the 0th element, or the head. Else we have to go through the list. So while temp is not equal to null, if the value is equal, we return the value or the index that the value is at. Else we increment the value, because now we know that the value will be a head in the list. It will be at keep ++ or more, and we keep traversing the list. So we check, is it equal, then we return the index it's at. Else we increase the index, and we keep traversing by saying temp is assigned temp.next. And if none of this returns anything, we simply return -1 as a default return value. Okay, so let's look at our remove function. So first we're going to say, what if the list is empty? So if is empty, then we're simply going to throw an exception. Why is it putting my bracket like that? Okay, so if it's empty, we're going to say empty list exception, and we're going to call it empty exception. Going to call it empty exception, and we're going to say it's a new empty list exception. And then we're just going to throw the exception. Throw empty exception. Okay, if that's not the case, if the list is not empty, then we're going to say else, and then we're going to handle the rest of it in here. Why does it keep pushing my stuff forward? Let me just fix my brackets up. Okay. So now what I'm going to do at the beginning is I'm simply going to output the size of the list. Remember we defined the size in the previous video. So size equals, we can say plus the size variable, so we can see the size of the list, and if it's obviously decreasing while we're taking out values or removing values. Okay, so then we're going to get the position of the elements. We can say this element posi over here, which we defined, is assigned get position, which is the function that I just showed you to get the position, and want to find that of value. And then we're simply going to output the position just so that we can see what it is for debug purposes. So we're going to say the position is plus posi. Okay, so now we're going to check our position variable, because that is what's going to determine how we're going to, if we're going to delete something or not. So if posi equals -1, well, we said that the get position function returns -1 if the element doesn't exist in the list. So then we can just return. Otherwise, if it's not equal to -1, we're going to do some deleting, because then we know it's in the list. So we're going to say if posi equals 0, then we know it's the head of the list. So then we can simply call our remove head function. Else, we know we can also check to delete the tail, so we can say posi. We know the tail is at the position, the variable that stores the size, -1, because we start at index 0, 1, 2, 3, 4, 5, and then size will store 6, for example. So we're going to say if posi is equal to get count -1. Get count simply returns the number of elements or the size variable. So if that's equal to get count -1, then we're going to remove from the tail. Okay. Else, we're going to want to find it somewhere in the middle of this, because then the element's not at the head and the element's not at the tail, so it's somewhere else within the list. Okay. So we know we want to going to decrement the size because we know we're going to remove an element. Then we're going to want to traverse the list. So I'm going to create a previous variable, which is going to keep the one before we are at. And the reason we're doing this is because it's if we're going to reassign pointers, then we might have to reassign. We're going to have to reassign the one before we're going to delete to the one after we're going to delete. We're basically going to assign over the one we're deleting in order to delete it. Okay. So we say dl node prev is assigned null, and then we say we create our current traversal elements. We say current is assigned head. I made the previous null because there's nothing to put in it yet. And now we're going to traverse through the list until we find the element. So we have the position. We have the position of the value that we want to delete. So in our while we can say while that position is not equal to keep position. Keep position we are going to increase within the while loop, and we're going to increase it until we get to the element we want to delete. And of course we want to check that the element we're going to increase in the loop is less than the size of the list, to check that we're within our bounds. Okay, so traverse the list. We're going to say that our previous pointer is going to be made our current pointer, so that we can move forward in the list, and our current pointer is going to go to its next. And of course, like I said, we want to increase keep pos. So therefore we know that we're going to increase this, and we're checking while this variable is not equal to the position we're looking for, and we keep increasing this variable until we get to that position posi, and also checking that it retains or stays less than the size of the list. Okay, so once we've done that, now we know we have the position of where we want to delete. So now we're going to say if current.next, so the next one of the one we delete is equal to null, or not equal to null, sorry. Well, then we know that we need to assign over the one we want to delete. So previ.next, which comes before the one we want to delete, is assigned currents next. So basically, previ.next used to point to current. So now we're making it point to the next of current, but we're checking that current.next is not equal to null. But what if it is null? Well, then we're simply going to say if current.next is null, then there's nothing to assign to. So then previ.next is just assigned null. So now we want to test our function, so our delete function or remove function, whatever. So therefore we have to write a main for it quickly. So this is the main I wrote. So we want to remove the elements, and it basically removes from 12 to 18, and then it outputs the list. So let's quickly go and rerun our application. Okay, and over here we can see what our insert did. Over here, and over here we can see exactly what our delete is deleting. So we want to delete the element 12, it deletes it, and it says the position is 5, 0, 1, 2, 3, 4, 5. And we do the same for 11, 14, 15, 16, 17, and 18, and then our final list is that.